right, so here we want to find the limit as x goes to 0 from the left-hand side. So that means we will cover up the right-hand side at x is equal to 0. And again, the idea is as x goes to 0, our little function values are going towards this y value, and that y value corresponds to 1. So we would say our limit is equal to 1. Now, for number 56, they ask us for the limit from the right-hand side. So we cover the opposite side. If we're coming in from the right, we're going to cover the left. So we just see this portion of the graph. As x goes to 0, our little function values are marching down towards this point right here. So that point corresponds to a y value of -4. And so that tells us that our right-hand side limit is going to be -4. Now, in number 57, they then ask what is the two-sided limit. So what is the limit as x goes to 0, no superscript, and that indicates both sides. So for that, you don't have to do any work. You have to use the number 55 and number 56 information, because when you look there, you see that these guys are not equal to each other. So since they are not equal to each other, that means that our two-sided limit is going to be a DNE. All right, now, if you look at the question, the other question, number 58 for this graph, you'll notice that the reason why we have a D and E is because there is a jump in the graph at x is equal to 0. But in 58, when they start talking about x is equal to 2, if you just look near x is equal to 2, there's no jump in the graph. So this limit will exist, and you can verify this looking at the limit from the left, the limit from the right. What will happen in number 58 is the limit from the left will march in towards this point. The limit from the right will march in towards that exact same point. And that point, of course, remember our limit is equal to a y value. That point is equal to 0. So our limit would be equal to 0 for the limit of f as x goes to 2.